The next concept that we're going to discuss is elasticity and scalability. Now this diagram in front of you you've possibly seen before in some other way, shape or form, but it's a diagram that's pretty much done the rounds of the internet, and it shows why organizations should think about using the cloud. Basically, we have a predicted demand here of a company, and they decide that their company is going to grow, their business is going to grow exponentially, at a rate that everybody has worked out will go like this. So at a point here they decide to spend a whole bunch of money, so that'll take them up to this point and they'll be ready for it, and just before that they can spend more money and keep on doing that. However, the business grows, the actual demand outweighs what they have in hardware, as you see this spike, and obviously that's not a good thing. There's going to be customers dissatisfied because you have insufficient hardware. Now that's where the cloud and AWS in particular like to trumpet how good they are, because they can pull EC2 instances in and out using auto scaling, which we will discuss a little further on. Now there's a couple of concepts that are thrown around, elasticity and scalability. They're very similar. There's probably a subtle difference between the two. According to Wikipedia, elasticity is the degree to which a system is able to adapt to workload changes by provisioning and deprovisioning resources in an autonomic manner, which means an automatic manner. That's different to scalability, as scalability is sort of, okay, let's cut to the chase and just, we can read all that, but the bottom line is elasticity does exactly what scalability does, but in an automatic manner. They like to use the word autonomic and independent from human interaction. So let's try and use elasticity instead of scalability, or if I use scalability, it really means automatic scaling up and down. And another quick snippet is auto scaling is a magic ingredient that allows a system that is hosted on EC2 to dynamically adapt to changes in demand. But how does it do it? How does it actually work? I'm glad you asked. There's a few I've written here. Auto scaling has two components: launch configurations and auto scaling groups. Really it has three, possibly even five, that we'll see later on. But first of all, let's explain the difference between launch configurations, scaling groups, and scaling policies. So launch configurations in a nutshell basically tell you what to scale, whether you need to scale in, what size instances you need to scale in, and what Amazon machine images the instance is going to be based on. So you could, if you get a high demand, you might go, let's bring in an M3 large in your launch configuration with a Ubuntu AMI or a Linux AMI, whatever takes your fancy. Scaling groups, on the other hand, manage the rules and the logic which are defined in policies. So I guess scaling groups and policies sort of tie in together, whereas launch configuration is what to scale, auto scaling group is where to launch it, and the scaling policy is how to launch it. Hopefully a little further on with the diagram and I'll explain it a little bit better. Some parameters that you'll come across on auto scaling. Now this is CloudWatch stuff. That CloudWatch is very well. It's needed. Without CloudWatch, you pretty much can't use auto scaling. It looks at all the parameters that are given to it by the various EC2 instances to say what its CPU utilization is, scaling group names, latency, request counts, and things like that. Probably not critical to the exam, but worth knowing about. And this diagram is just showing you, doesn't show you, go into too much detail about the auto scaling itself or the elasticity, but just to show you that you could possibly have a setup like this where you have a whole lot of EC2 instances at the ready to be brought in or out whenever you feel like it. Now notice they're across availability zones, not regions. In the next slide we're going to see a scenario where someone has set up across US East 1A and US East 1B. They've set up a bunch of EC2 instances across each one, and for instance, let's say that their policies spread across both these groups, and they can bring, depending on how you set up your policy, you can bring in instances from here, instances from there, shut down instances from here, and so on and so forth. Once again, stipulating CloudWatch is needed for this. And across regions, it cannot be done. So if you set it up, if you have any ideas of setting up auto scaling across regions, it pretty much can't be done. Okay, now this is a pretty good drawing which sort of sums up all the concepts. And now we talked about launch configs, auto scaling groups. There's a couple other things here that we need to define. One's a trigger. Now it triggers a CloudWatch alarm and an auto scaling policy that describes the actions of when the alarm threshold is crossed. So a trigger, you can have triggers for scaling out and scaling in and scaling out, pretty much. And a policy is a set of instructions for auto scaling that tells the service how to respond to CloudWatch alarm messages, and alarms are just alarms. To really understand this, I suggest that you try and set up your own auto scaling architecture. The good thing about AWS is you can go in, you can set up a whole bunch of architecture and pull it down at the end of the day. It's not going to cost you anything, well, small amount that you use to run it that day. And if you're on the free tier for 1 year, you can pretty much get it for free as long as your instances aren't too large. So I can go through this ad nauseum, but to really understand it, I think you need to set it up yourself. Set up auto scaling groups, some rules, scale up and scale down using CloudWatch. Again, note that auto scaling needs Amazon CloudWatch monitoring service to function, and Amazon CloudWatch is built on a usage basis. That's just a minor point. Now this example, case 1 we'll call it, is using auto scaling with elastic load balancing. Now you can use auto scaling with or without elastic load balancing. Now in this example, the architecture is suitable for web layer only. So the elastic load balancer is attached to the auto scaling group in step 1. In step 2, the ELB acts as the gateway and transfers the requests to Amazon EC2 instances in a round robin schedule. Third step, the instances are configured then to be part of the auto scale group. And finally, the auto scaling launches new instances. And then number 5, it's just stated that auto scaling, CloudWatch, and elastic load balancing work in unison, I think they mean to say. So in this next example, it shows you a case where auto scaling can be used without elastic load balancing, and it uses SQS instead, and basically the messages that are needed for processing are put in a SQS queue, and then the EC2 nodes can control the scale up and scale down of the processing nodes tell the instances to go up or go down. So just be aware that you can use auto scaling without elastic load balancing. And this pretty much sums up what we just saw in the first case, where we used auto scaling with elastic load balancing. So auto scaling supports but does not require elastic load balancing, and we can add elastic load balancing to our auto scaling group and use elastic load balancing metrics, latency or request counts, etc. And if this has seemed pretty confusing, auto scaling, once again I suggest you need to practice to really understand the concepts. It's part of this exam that's pretty hard to memorize, and you really need to do it, I think. So again, I encourage you to get in there and build some auto scaling groups, policies, play around with it, rip it up, rip it down. And this slide basically says auto scaling is an art, but every situation is going to be different, and you know, it's got to be tweaked, it's got to be played with. Just by deploying our application AWS doesn't mean that our application will leverage auto scaling, scale out automatically. So to leverage it effectively, you really need an in-depth architectural understanding in both the application and the infrastructure. So, but you know, again, I talked a lot about this course is really about passing the exam. So that is a concept you need to wrap your head around, but what helps a lot, I think, is to go through questions, and there'll be more questions about auto scaling in the exam. We have an 80 question exam at the end of this, so don't panic if you didn't fully grasp everything I was trying to get across there in regards to auto scaling and elasticity. So as an example, the question in front of you is one that I've seen pop up, or a similar one, and it says, which of the listed items is auto scaling not capable of doing? Emphasis on the not. So let's go through them one by one. Spanning auto scaling groups across multiple availability zones within a region. Now, if you remember back at the beginning of this, or sorry, about halfway through, I had two examples, one where they scaled across availability zones and it worked, and the other one where it scaled across regions and it didn't work. But what they're saying here is, can you span across multiple availability zones? Yes, you can. Okay, stopping an instance if the CPU utilization is above the threshold that has been set. That seems reasonable to me. Stopping an instance if you hit a certain threshold, so I think that's okay. Increasing the size of an instance if the CPU utilization is above the threshold that has been set. That sounds like it would be a bit more complicated to just start shutting down an instance and bringing in a new sized one. Let's just have a think about that, and we'll go to the last one. Starting a new instance if the CPU utilization is above the threshold that has been set. Now that seems pretty simple to do. I mean, need another instance. Just yeah, bring one in. But yeah, to me, this one is the one that's probably not. It's not going to be able to do it because of the fact that yeah, it's the most complicated of the four, I would say. So let's have a look at the answer, and it is in fact C, increasing the size of an instance. And the reason for that is pretty much at the bottom of this. I mean, you can read the whole thing, you can pause the video and read the whole thing, but it's just a basic fact that auto scaling cannot increase the size of an instance if the CPU utilization is above the threshold that has been set. Okay, so that's it for auto scaling, elasticity and scalability. Now I think this is probably, out of all the concepts in VPC, the hardest to grasp. I mean, it's possibly easy to understand, but the intricacies of it can be a little daunting. But again, don't panic too much, because we're going to have a few more questions at the end in the exam that hopefully will help you out a little bit more. Okay, well that's it, and I'll talk to you again in the next one.